I am Dr. T. Asan, Assistant Professor, Department of Computation Intelligence, SR Institute of Science and Technology, Kattangalottu. As a continuation of the previous video, we are going to see about Knapsack problem part 2. Here we are going to see about state space tree. In the state space tree, we are going to see about upper bound calculations. Here, initially W is equal to 0 and V is equal to 0 and upper bound equal to 0 plus, that is 0 is small letter w plus capital W minus small letter w into Vi plus 1 by Wi plus 1. 0 plus 10 into V0 plus 1 as initially the value of I is 0. So 0 plus 1. So 0 plus 10 into V1 by W1. 0 plus 10 into V1 by W1 is first value by first weight, that is 10. 10 into 10 is 100. So the first value will be 100. Next value calculation, we said that the left is inclusion and the right is not exclusion. With and without. The first item is included in the left and the first item is excluded in the left, right. Next, W equal to 4 and V is equal to 40, which means that first weight and first value is considered. When first weight and first value is considered, this is the formula for calculation of upper bound. V is small letter v, that is 40, plus capital letter W is the weight given in the problem, that is maximum capacity of the knapsack, that is 10, minus 4 is the weight for the first item into Vi plus 1 by Wi plus 1. Vi is I value is incremental by 1. So I value is 1 plus 1. W 1 plus 1. 40 plus 10 minus 4 is 6 into V2 by W2. That is 6. 40 plus 6 into 6. 40 plus 36 is 76. Now by including the item 1, we get the upper bound of 76. By excluding the item, excluding the item means no weight is considered, no value is considered. So W equal to 0 and V equal to 0. Upper bound equal to V plus capital W minus small w into Vi plus 1 by Wi plus 1. Upper bound equal to 0 plus 10 minus 0 into Vi plus 1 is I value is 1, 1 plus 1 by W1 plus 1. That is upper bound equal to 0 plus 10 minus 0 is 10 into V2 by W2. V2 by W2 is, but weight 2 by W2 we got the resultant is 6. So 10 into 6 is 60. So as per the concept of upper bound, we have to have the maximum profit. So upper bound is considered and the maximum value is considered. Among 60 and 70, 76 is the maximum value. So that is considers the promising node and that node alone is expanded. So 76 is considered and with the 2 without 2. That is here in this step we have added 1 and excluded 1. In the next level we have to find the promising node 60 and 76. We have find the 76 as the promising node because this is the maximum value. So next step is including with the second item and without including the second item. When including the second item, that is W is small letter w is the weight, including the second item is weight 4 plus weight 7. 7 plus 4 is 11. But the maximum capacity of the knapsack is 10. As weight excludes the value of the maximum capacity of the knapsack, we are not going to consider this step. This is discarded. And you are without adding 2 means you will be having the value of first value and first weight term only. W equal to 4 and W equal to 40. But I value changes. Here I is, in this level I value will be 1. In this level, I value will be 2 because each level the I value increases. For level 0, we had the I value 0. Level 1, I value is 1. Level 2, I value is 2. Small letter w plus capital W minus small w into Vi plus 1 by Wi plus 1. Small letter v is, that is the value 40 plus capital W is 10 minus W is 4, 10 minus 4 into Vi plus 1 by Wi plus 1. Vi is 2 plus 1 by Wi plus 1 is W2 plus 1. 40 plus 10 minus 4 is 6 into V2 by V2 plus 1 by W2 plus 1 is V3 by W3. That is weight 3 and value 3 are divided. Those combinations 5. That is taken as input. 40 plus 6 into 5 is 70. As per the concept, we will calculate the maximum value among the given resultant. Here, as inclusion is not considered, only possibilities we have to take this. Next step. Here, upper bound is equal to 100. This is calculator. First level, second level is calculator. We go for the third level. Third level means here item 1 is considered, item 2 is considered. Third level, third item is going to be considered. So the I value will be 1, 2 and I will be 3. Now, which means that we have to consider first weight and value, and we should not consider second weight and value, and we have to consider third weight, and we have to not consider the third weight, with third weight, without third weight. Now, first weight without second weight and third weight is considered is weight of 1 plus 3 should be considered. Weight of 1 plus 3 is, first weight is 4 and 5. 5 plus 4 is 9. V equal to 40 plus 25 is 65. Weight and value of 1 and 3. Upper bound equal to small v plus capital W minus small w into Vi plus 1 by Wi plus 1. Small letter v is 65. That is weight and value of 1 and 3 are added together. 65 plus 10 is the capital W, that is capacity of the knapsack, minus small letter w is 9 into Vi plus 1 by Wi plus 1. Vi plus 1 is I value is incremental by 1, that is 3 plus 1 by W3 plus 1. That is 65 plus 1 into V4 by W4 is V4 by W4, that is V4 by W4, that is value 4 divided by weight 4, that is 4. 65 plus 4 is 69. Here, next, without 3. Without 3 means we have to consider only 1, without 2 and without 3. So, only first value and first weight alone should be considered. W equal to 4 and value equal to 40. Weight and value of 1 should be considered. Upper bound equal to V plus W minus W into Vi plus 1 by Wi plus 1. 40 plus 6 into V3 plus 1 by W3 plus 1, that is V4 by W4, fourth value divided by fourth weight, that is 4. 40 plus 6 into 4, that is 64. We have two values. In this, the maximum value should be considered. You have got the upper bound of 69 and upper bound of 64. The maximum is 69. That is considers the promising node, and that should be expanded. Here we got this set of values. Upper bound 76, 60, maximum is 76. It is extended. Here we get, it is not feasible because it exceeds the maximum capacity of the knapsack. We consider without 2, 70. Here we have calculated two values by adding 3 and without adding 3. So with adding 3 and without adding 3, you will be getting the maximum values with adding 3. So this is considers the promised node and that is expanded. Here I value will be 1 in this stage, I value will be 2 in this stage, and I value will be 3 in this stage. When we extend the stages, the I value will be increased to 4. Here by adding 4 without adding 4. By adding 4 means here with 1 means adding 1 without adding 2 with 3 with 4. So we added first item, third item and fourth item. That is 1, 3 and fourth item should be added. 1, 4, 5, 3. Adding 5 plus 3, 8, 8 plus 4, 12. So totally adding the weight of 1, 2, 3. That is weight of the first item, weight of the third item, weight of the fourth item added. We get the next level W equal to 12, which is the next level indicates that it exceeds the maximum capacity. When it exceeds the maximum capacity, we say that exceeds the maximum capacity means that is discarded. Next, without adding 4, we are going to get, we are adding with 1, without 2, without 3, here with 3. You are selected with 3, with 3, without 4. So we have to add only first value. No, second value is not added. Third value should be added. Fourth value should not be added. So only first and third value are added. That is first weight is 4 and third weight is 5. 5 plus 4 is 9 is taken and value is 40 and 25. 40 plus 25 is 65 is considered. Weight and value of 1, 3 should be considered. V plus W minus W into VI plus 1 by WI plus 1. That is 65 plus capital W is 10 minus small w is 9 into Vi plus 1 by Wi plus 1. I value is 4 because we are in the fourth level. First level, second level, third level, fourth level. When V4 plus 1 by W4 plus 1, which means that V5 by W5. Here we don't have any fifth item. So we place it as 0. 65 plus 10 minus 9 is 1 into 0. That is 65. As per the concept, the maximum value should be considered. The left we had discarded because it is exceeded the maximum capacity. The right is the only option that is considered. The next, this is the final solution for this input. And finally, final solution we have consider this as the final solution by the weight and value of 1 and 3. 1 and 3, 4 and 5, we got the weight is 9 and value is 40 and 25, we got the value and weight is 40 and 25 is 65. This is the capacity in which we can load in the knapsack effectively. 1 and 3 add panna value store pannalam effective. அப்போ வந்து 1 and 3 is about 9 weight with 40 plus 25, $65 can be placed. This is the maximum capacity in the knapsack problem.